Okay. Okay. So can everyone hear me? 线上同学可以哈。All right. So any questions before we start? No. Okay. So 有没有什么问题 ？Questions? Any questions before we start? Okay. So we have homework 2 release maybe very likely today, and we'll do next Monday. And we have exam 1 next Tuesday. So that everyone know. 所以我们会有第二次功课跟第二次功课应该今天会公布，然后下个礼拜一 due， 然后星期二考试。So after the homework due, there will be reference answer that will be released online， 就是会有参考答案给你看，参考答案就叫做参考而已，不一定会是对的。所以就是可能的答案长这样子。Okay? Any questions? There's something I want to talk about first. 重画 I want to clarify one big idea, and I know this idea will be pretty confusing for most of you, even still right now. We have, let me draw the figure again. We have a CPU here, right? And in the CPU, we have registers. We have 32 registers. Each register is a double word register. Okay? And we have memory. We have memory. And this memory is counting from position 0 to 1, 2, 3, 4, 5, all the way to max. From 0, 1, 2, 3, 4, 5, to max. Okay? That is good for everyone, right? And each register position is a byte. 这个可以吗？这是一个 byte。等下我画错，我重画一次啊。你这样不好讲。这样子讲还是这样子讲？ This is a byte. Okay? And 4 byte is a word. 4个 byte 组在一起叫做一个 word， 然后你在 memory 的位置里面呢，移一格是1个 byte， 所以一个 word 你要移4格，1、2、3、4，因为一个 word 有4个 byte， 这个 OK 吗？哈 ，So this is okay for everybody. So in the CPU you have registers. And there's a memory in this system. There's a memory. Memory has address. Memory 有位置，位置0、1、2、3、4一直到最后最大。And each address, 1 unit, corresponds to 1 byte. 一个位置就是一个 byte， 然后就1个 byte、2个 byte、3个 byte 这样子 ，OK? And one word has 4 bytes. Of course, double word has 8 bytes. 就是一组基本的资料，原则上是一个 word， 那个基本的资料 word 叫做4个 byte 嘛，所以你要跳4格。If your first word is at position 0, your second word will at position 4. Your third word will at position 8. 8, 9, 10, 11. 那4个 byte 就是第3个 word。Of course, if you're using double word, 你只要是一个单位，你在做的单位一次是一个是 double word 的话 if that's a double word, then you need to jump over a unit, 8个 byte, right? Okay. First of all, is that okay for everybody? 这到这边有没有问题？没有啊。All right. So now, what is the address? What is the address? What is the data in the register? So data, these are the register. Registers are storage elements inside CPU. It has 64 bits. 在 RISC-V 里面是64个 bits. Right? From here to here, that's 64 bits. You can store the data, whatever data you want in there. Of course, you can store address in it. 你的暂存器里面可以存1、2、3、4、5，随便你要计算你的薪水，你的什么住址都可以。Whatever data you want to store in the register, but it can also store memory address. 它也可以存记忆体的位置。Okay, so we use. If we want to point to a register, point to a memory location, for example, here, want to point to a word somewhere here. I need that address. If this address, this data B. Data B is in the memory. Okay, so data B is in the memory. Data B is in the memory, and it is somewhere in the memory, and it has an address. 它在一个位，就像你的住址一样，的座号一样。这个 B 是那个资料的内容，可是这个资料呢，放在记忆体里面的某一个位置，它有一个位置，它有一个 address， 它有个住址。这件事 OK 吗？ So there are two concepts. One is the data B, and this data B is in the memory at the address. Address, let's say address X. 我们假设 address X 好了。So data B, 我不要讲 data B 啊，我讲data B 啊。Data B could be your I don't know, your password. Data B is your password. And this password is stored in a memory at an address X. So this X and the B are two different things. 这可以接受吗？哈，一个是你的存款簿的编号， 一个是你存款簿里面有多少钱，那个 B 就是你存款簿里面有多少钱嘛，对不对啊？10块、20块啊。那另外一个是存款簿不是都会有个编号吗？就是你是这个银行的第几个存户，它会存在它的 database， 那个叫编号。所以编号跟你存款簿里面记账记了多少钱，这两个是两回事，不要搞混。So far so good， 来到这边可以哈。So how do we find B? How do we find B? We need a place. We need a data. This data is the address of B. 我们要知道 B 的 address 在哪里。那个 address 呢，对 CPU 来说其实也是 data 的某一种，它放在 register 里面。Okay, so I put, for example, if I have register 1, I put X in there. 我把 X 这个位置、这个值哦、这个住址哦，存在 R1 里面。I put this address into R1, and when I need to load the data B, I will load to, let's say, R10 from R1. 这样可以吗？我是从 R1 指到的那个地方 ，R1 里面存了一个值，我不知道它是什么，但是后来我知道了，它是 B 的这个 data 的位置，所以我在 load 的这个指令里面，我就告诉电脑说，我要从 R1 里面记录的那一个的位置，把那个值我不知道什么 load 回来，放在 R10。那load 回来，我们现在知道它是 B 嘛，所以这个就会变成是你的 R10 里面就会这个 data B 就会漏回来放到 R10 里面，可以吗？这个概念可以吗？因为我知道很多人搞混 ，confusing this concept. So is that okay for everybody? 快出来。What happened? Is that okay for everyone? 为什么没有出来？好，这个 OK 吗？到这边为止，B 出来了哈 ，B 在那里。OK， 可以哈。All right, let's get back. 所以 So in a register can store the data. 1, 2, 3, 4, 5, and your whatever. Register X can also store the address of the data in the memory. 所以暂存器可以存你平常要存的 data， 平常要存你的账户密码都可以。X 里面这个register 里面呢，也可以存你要去 memory 找的资料，那个资料所在的位置，然后你用这个位置去找到这个资料 ，OK？ 那这个register 呢，在这个状况下，有时候我们会叫它 pointer， 就是指标了啊。All right, any questions so far? Okay, so so in the CPU, we have registers. In the CPU, we have registers, and these is memory， 这个叫做 memory， 就是跟我刚刚画的是一样。So it's the same as what I drew before in the previous slide. The one on the right, that figure is the memory layout. Memory 的使用方式哦，哪一个 address 用什么事情 ？Okay, so CPU can load or store data to the memory or load the data from the memory. Okay, is that okay? All right, so for the memory layout, for the right-hand side, you see that the memory has different addresses from 0 at the bottom all the way to the max on the top. And this is how a computer, usually a computing system, use the memory. So starting from the bottom, you will have a region that is reserved area. The area that nobody can use it, that's reserved for system. 就是保留下来给系统使用的区域，底下那个灰色。So that gray area is a reserved area, and on top of it, from that somewhere to somewhere, that's called text. Text is the memory region, memory 的位置区域啊 ，a region of the memory that store your program code， 程式码，你写的程式码。And on top of it is your static data. What is static data? 就在你程式码之外，上面存什么呢？那个是存叫 static data. What is static data? That's your global variables. The variables that you need across different functions. 就是你这些各式各样的 function 都需要用的这个变数存在那个地方哦。For example, your static variable in C, your constant arrays, your strings. And the X3 register, if you recall, 第四个 register 叫 X3 嘛 so X3 is one of the register, and in the register usage, we use it as the global pointer. So that means for this register, usually it stores the address in this area. 大概就只在这个地方 X3。So X3 is a global pointer. The nickname for X3 is global pointer， 叫 GP 嘛，对不对？之前我们有那个 if we go back to register usage, you will see different usage of registers here. So X3 here, we use it for global pointer. That's usually people use it to store the address in that static area， 就是它会存在那里，它会存那个位置，只在那个位置的一个pointer， 只在那个地方。So it's easier for the program or the CPU to access the data on top or lower of this area. So with that X3 pointer, I can easily access that static the data in the static data area. 对吗？我就可以很简单。往上加一点，往下减一点，我就可以去那个位置拿资料。So we also learn the stack pointer. We also learn the stack pointer. Oh, let's talk about the heap first. 这个地方叫做 heap， 叫做 dynamic data. So that is the area that whenever your program needs some memory space dynamically at runtime， 就是你在写程式的时候，你有没有 call 过一个叫 malloc memory allocation？ 写 Python 的人应该不会写这个，写 C 啊 C 加加的人，你们有 call 过一个 malloc？ 哎，这里 malloc。Have you called a malloc asking the system to give you a space, a memory space of 128 bytes, for example？ 给我一个这么大的记忆体位置。So where does the system find you this space? From that dynamic area. So if the system gives you 128 bytes, it will move it will record, okay, this 128 byte is already used by you. So it will record it and then reduce the size of the heap, size of the dynamic data area. Okay, that's dynamic memory allocation. And another memory layout space is called stack. 在上面啊 stack. So stack is counting from the max address downward, 从上往下走. That's why, if you recall in the program, when you need more stack, you minus the address. 你记得吗？你要多一点的 stack 位置的时候，你不觉得奇怪，它怎么用减的？因为它是从最大的地方开始往下走。So stack pointer, for example, is here. If you need more stack space, if you need extra 2 more space, you have to go down to get more stack. So that's how you operate it. Okay. Yeah, question. It 它只在 static 那里 ，static variable 我现在指的那里是 static 啊。没有 depending on, so the question is, where does this x3, which is the global pointer, pointing to? We just know, usually the way you, 这个是约定成熟，你不要这样用也可以。So x3, first of all, x3 is a general purpose register. You can use it any way you want. But usually, people use it as global pointer to pointing to somewhere in the static area, somewhere in the static data, somewhere. Doesn't not necessarily be anywhere, somewhere in there. The purpose is for you or for the compiler to easily manage or find out where the data you need. 就是它只是让你方便直接跳到那个区域的上下去找到你要找的资料。谁负责这件事啊 ？Usually compiler does the management. Compiler will move this x3 is managed by compiler. The compiler will decide where I want to point to. If I use a lot of my data, it will be used in the upper area, then I will probably move my x3 pointer to the upper area. If most of my data will be used at the bottom of the static area, then I'll move down. So that purpose is for the program to find out the data that it needs easily. 比较容易找到他想要找的资料，这样的。管理怎么管？纸在哪里？要不要上下移动 ？Compiler。You only have 30 question. The question is, if you need to record more addresses, but you only have 32 registers, what do you do? Right, that's your question. If I transfer the question, transform it into a different way. I need to store more data, but I only have 32 registers. What should I do? 你会怎么做？我要存一堆资料，可是我就32个暂存器，我怎么办呢？剩下多的资料我会放在 I will put it in memory. I'll put it in somewhere in memory. Say I need, I don't know, 128 more bytes to store the data. Doesn't matter what the data is. 我不管那个 data 是什么，是 address 也可以，是你的 password 也可以，是你的 account ID 也可以，不管是什么，我需要128 byte，我就去跟系统要，系统就会从 dynamic 那里给我，他就给我128 byte，我就存在那里，我要的时候拿来用。用完再把它 free， 记得 malloc 完要 free。看来有人在写 C code 吗 ？malloc 有用过的举手一下。有啦，很多人都用过，好像让我感觉都没有人用过。OK， all right， so okay, so if you look at this, that will be the local data on the stack. So this is the frame pointer. Frame pointer 就指在你的 frame. So each frame pointer points to the procedure frame. That is the zone. That's the area of the memory that will be used by this procedure. 就是这个 function call 的 需要用到的资料先存在那。So after this function call, this function is terminated, this area will be released. Okay, so if you are in a function and you call the next function, then you have to create a new space. So from here, you create a new space here. You create a new space to be used by your new function. And after your new function is terminated, you release this space and come back to here. So come here, you call a new function, you create a new the friend buffer, the friend area. And after your function is done, you release this memory space and return back to here. Okay, now, 这个是 stack 的，这是 stack. That means if you need more things, you ask for it downward in a downward way. 你从下面要更多的，下面用完之后，你就把它清掉，再回到上面。它是反过来，你或者你倒过来看，这样可以啊，看你要怎么看，头会比较酸呢。Okay, all right. So there are different types of data. 不同的 data, there are different types of data. One is called character, 叫做字元呐，就是 ABC 啊，大写小写，罗马数字啊，阿拉伯文字啊，中文 ，even Chinese. Okay, there are different types of character, but in the beginning there are only like Latin word or like American words, characters. So it is in the beginning encoded in 128 different characters， 就是以前呢，就是你要怎么代表 A 啊？你要怎么代表 A、B 大写的 A 这件事情，这个困扰了很久。每个人代表 A 的方式不太一样。So there are different ways to represent the character. So then there's the standard came out called ASCII, American Standard Code for Information Interchange. ASCII, ASCII, ASCII. It has 128 characters with 95 graphic character and 33 control. 有95个是字元、字形、图形啊，有33个是控制嘛，是换行啊之类的这种，或是这个每一行的结束啊这种东西 control code. And later be extended to Latin one which has 256 characters. 这个只有西方字母啊，只有这个 Western characters, like alphabets. But it's not enough. When a computer is spread out worldwide, you need more character sets. You need to support more character sets, like Chinese. How many characters in Chinese? 你知道中文有几个 characters 吗？中文有几万个 character， 可能5万到10万 character， 不知道中文字到底有多少个啊？这种数字。Anyway, you need the character set to support this. Chinese is one, Japanese, Korean, Arabian, different character sets you need to put them into support. So there's a new worldwide standard called Unicode, has 32 bits to support different characters. 它现在就把它延伸到32 bit， 就2的32次方，这么多的 character 你可以记，看你有几个，一定够了啊。So in that way, the computer system can support different character sets. All right, so for the computer to support different data type, then the instructions need to support different load or different store. So you can load byte, load word, load word, load 一个 byte 就是 load 一个8个 bit, load one byte, load 2 bytes, 2 bytes is half word, 2 bytes 就叫半个字嘛。And load a word 就是一个字4个 bytes. So you can, based on your need, you can load how many bytes from this position. Okay. So you can load it in a signed manner or unsigned manner. Sign 跟 unsigned 就是有没有正负号的意思嘛？有没有正负号差别在哪里？ Sign means you have positive value and negative value. It's called sign. When you load a byte, then store in the register 64 bits, 8 bytes. you need to do sign extension for the rest of the 56 bits。当你漏的只有正负号，而且你只漏8个 bits 的时候，你需要把那个 sign bit 延伸，叫 sign extension 嘛？我们讲过，对不对？可以哈。So if you load the data as a sign value, you need to do a sign extension. Otherwise, you just load as is， 就是直接漏进来放进去，剩下的放里面就好。So you can decide. You have to decide. You want to load it as a sign value or unsigned value, depending on which instruction you use. Of course, when store has the corresponding instructions, store by, store half word, store a word, or store double word. SD 叫 store double word 或者是 LD， 前面看到LD 有没有 ？Load double word, store double word. Okay. All right, string copy example. This is the copy string. You copy from Y string to X string until you hit the end of the string. The end of string is defined by null terminated. That's a null， 就是ASCII code 里面的代码0就是一个 null 的意思，它就代表字串结束。你就是从 A 字串一直 copy， 每个字都 copy 到 B 到 Y 字到 X 字串，直到最后一个字元 copy 完，这么简单。So copy character by character from string Y to string X until the end of the string. Okay, so that's easy. You translate it into the assembly code. It looks like this. So first of all, you push this x19 into stack. If x pushed out stack, x19 pushed to stack, because you will use x19, but you don't want to lose this data, so you push it to the stack, and then you set it to 0. 这个是 set x19 to 0. 你把 x 0, so you add x0 to x0, which is still 0, and you put a result into x19. That's also 0. That's a reset. 这个是 reset 的意思哦。All right, and then you calculate the address of x, address of y. So the base register for y is stored in x10. 你找到 y 的第一个点，就是 y 是一个字串嘛，就第一个字元就是 A B C， 它的 A 在哪里 ？A 是第一个位置 ，B 现在 C， 然后 B， 找到第一个位置。So you calculate the starting point of array, the string y. You load it, and you calculate the address of X array, and you store it. 你算出 y 的起点，然后你把那个 y 的第一个资源漏进来，然后你算出 x 的位置，然后你把这个漏进来的东西存到 x 的第一个位置去，就这么简单了。Okay? And then you compare if it's the end of the string. 比看是不是0啊？是不是0跟0比看？是0 ，if it is 0, that means the end of the string. You jump to L2. You jump to L2 and end the process. Otherwise, you just increment the index. 你把那个 I 加1再去比，再去漏下一个，直到你的那个。So you increment the x19, and then you jump to L1 and do this again. Okay. You keep load the y character, store to x character, and compare if it's the end of the string. If not, jump and do it again. Load the second character, store to the second place of the x array, and check if it's the end. If it's not, do it again until it's the end of the string. Then you jump to L2 and end the process. Okay. Why does x19 is only incremented by 1? how many bytes in a register? 我们的这个 register, how large is it? 64 bits, which is 8 bytes. So we say if that's a double, if each element is a double word, we have to jump 8 for each element. 我们每拿下一个资料它是8个位置以后，为什么它这是只加1呢？ Why is it only incremented by 1? Because it's character. 字元呢 because it's character and character is only recorded as 1 byte. 一个字元只占8个 bit, 8 byte. Sorry, 1 byte. 所以你一次加1就够了，因为一个加1就是 byte, 就是一个 byte, 加1就是一个 byte. Making sense to you? 看不懂要说。Alright, so 32-bit constants. Most constants are small. Remember, we have the immediate format. 我们有一个 instruction format 有 contain immediate. So that only has 12 bits. And you can specify the value from positive 1024 to negative 1000. 是14还是12忘记了。反正就是正负2000、2000、4000这个位置，好像是12。Yeah, 12 bits. Okay. 对，12。So for usually the instruction, the immediate can only specify from positive 1024 to negative 1023. 正1024到1023到负1024啊，大概这个 range. What if you want to specify much larger constant? 你要 specify 你要给一个大于这个正1000多和负1000多，超过这个范围的数字，怎么办呢 ？What do you need to do? What can you do? Several ways. You store it in the data in the memory, and when you need it, load it. 对不对？就把它放在 memory 里面。你需要这个银河系有几个恒星这种数字啊，存在 memory 里面。你要的时候就把它拉进来就好了。Okay? But can you encode it in the instruction? 你可以把它放在指令里面。你可以把它放在指令里面，你就不用去 load 资料进来。你拿到指令，你就知道那个值是多少，就是要加3、加4或加7的这个7这个常数项，你就知道。你可以把它放在指令里面吗 ？Can you put it in the instruction? In the current format, you can't. You can only specify. You only have 12 bits. What if you want to specify a constant that is 32 bits? 你要 specify 一个常数项，它需要32个 bits. 怎么办呢 ？You need to combine 2 instructions. One is the first one is called this one LUI. It's called load upper immediate. It will load 20 bits of the constant and then put it on the top of the 32 bits. 就是把20个 bit 放在32 bit 的上面，那个20就是31到多少？31到12。And then you do the second instruction to add it with the 12-bit immediate. 你就是他给你一个指令叫做 load upper LUI load upper immediate. So you can load these 20 bits. 上面那个20 bits. You can load these 20 bits to the upper part of the 32-bit area. And then you do that lower 12-bit immediate again. 你再补上下一个指令你再补上下面12个。你再把它加上去，这样就好。Then you have 32-bit constants in your register. Okay? 那讲64怎么办？这个是好问题，说明考试会出。Question so far? Yeah. LUI is it is load upper immediate. That will put 20 bits constant to the upper side of the 32 bits. 就是32 bit，32从0到31，对不对？你假如要给一个常数，你只能指定到它的 L， 就是比较低位数的那边12个 bit， 对吧？哈，上面那里20你 touch 不到，因为你的指令没那么长，你的常数项就只有12个 bit。这个指令呢，这个 LUI 这个指令呢，给你20个 bit， 让你放在那个上面20那里，他就做这件事而已。他就让你去指定上面那个20个 bit 那个位置你要放什么上去。放完之后，你再把下面12个 bit 加上去，你就有一个32 bit 的值是你完全指定的，对吧？可以啊，可以吗？哪里还不确定？你是说第二个指令怎么加吗？就是把这一个这里你的指令里面会有一个1280，它其实是500的意思嘛，它就是把这个500就是这个就是500，你就把这个500呢加到这个上面去就好了。就是说我假如要指定一个常数，我假如要指定一个常数是789好了，789，可是你的指令只让你 specify 9，那你7和8怎么做？他就给你一个指令，先 load 这个7跟8，所以你的 register 里面就有7、8了，就有7跟8在这里，你的 register 就有7、8、0在这里，然后你再 add 9，在这边7、8、9 ，OK 吗？load 7、8、0 ，OK。All right. Branch addressing. So when you want to do branch, branch is the instruction that you need to jump like this. This is called branch. You can branch. Usually when you execute the instruction, you execute your next instruction, right? We call the sequential programming model. 你要执行下一个指令嘛。执行完这一个，做完了再做下一个，做完再做下一个。可是有的时候 ，somewhere, sometime, you need to jump over or jump back。你有的时候往后跳或往前跳，跳过一些指令。Sometimes you need to jump over, jump forward, or jump back. That instruction is called branch or jump. Branch is usually based on condition. Okay, so for condition addressing. You have OP code to register to make the conditions and the target address. So most of the branch targets are near branch because you only have 12 bits. 你只有12个 bits， 你要 specify 只能往前跳多少，往后跳，往前跳1000多，往后跳1000多，这样正负1000多。Okay, so branch can only branch to an instruction that is not too far away from your current place.Making sense? 可以啊。Branch 你只有12个 bit， 即使有正有负，你只能选择现在这个位置，往前跳往后跳1000多，或往前跳1000多，在这个 range 里面而已嘛。你假如要跳到往前5000，往后4000，你跳不过去。Okay? So what do? You need a longer branch, or some people call it jump.So in different instruction format, this one gives you 20 bits. 它让你可以跳到20个 bit 这么远。So 20 bits is like what? 2的20次方，2的19次方正，2的19次方负，这么远，比较远啊。So you can jump over farther away. So this UJ format can give you 20 bits of immediate for larger range. Hey, this is not what happened. 这群组，哎，我上次是不是有这个问题 ？Oh no! What happened? So everyone online, please switch to this one.